This is Higher Maths, it's practice paper D, and we're looking at question 21 from the non-calculator paper. Right, so what I've done so far here is I've written down the coordinates of A, B and C just to make it a bit clearer on the diagram that we've got here. We know that they're the vertices of triangle ABC, and what we have to do in part A is to write down the equation of the altitude from C. Okay, so the altitude from C is quite a straightforward one, and it's only a 1 mark question, so we're just going to put down the equation straight away. What I can see here is that the coordinates, or the y coordinates of A and B, are the same, they're 4, so that tells me that that line AB is parallel with the x-axis. So if that's parallel with the x-axis, it would have a gradient of 0, and then there's a right angle here for the altitude from C, so the gradient would be undefined there. And when we've got an undefined gradient, the equation of that line is just going to be an x equals line. And I've got x equals 4 here already. All it is I'm using the x coordinate of C to work out the equation of that line. So x equals 4 is just written straight down from there. Next part, for part B, I have to find the equation of the perpendicular bisector of BC. So we're going to have to bisect this line, cut it in half and find the midpoint, then find the gradient and then the perpendicular gradient, and then substitute into the equation of a straight line to get the equation of the perpendicular bisector. Right, find the midpoint first of all. So the midpoint of BC, and what we'll do is we'll just take the mean of the x and the y coordinates from there. Right, so what we've got is 10 and 4, so 10 plus 4, and we'll divide that by 2, and we'll go for 4 plus 8, and just divide that by 2 as well. What that should give us is the midpoint, which should give us 7, and that will give us 6. Okay, so there's the coordinates of the midpoint of that line. I'll then work out what the gradient of BC is, and the gradient just using the gradient formula, and substituting in from there. So we'll go for 8 minus 4, and we've got 4 minus 10, which should give me 4 on the top there, and on the bottom I've got a minus 6, and just simplifying that out would be minus 2/3. I'll then look at the gradient of the perpendicular. So the gradient of the perpendicular of BC is just going to be equal to just flipping the fraction around and changing it to a positive, so that's 3/2. Okay, now I've got the gradient of the line that I'm interested in, and I've also got the point that I'm going to substitute in. What I'll do is I'll just substitute the gradient, that'll be the perpendicular gradient, and what we'll do is we'll substitute the point 7, 6, and we'll put that into the equation of a straight line. Okay. Right, from there, here we go. We'll go for y minus 6 is equal to the gradient, which is 3/2, and that's going to be x minus 7. Okay, and I'd expect to gain my mark there for the equation of the perpendicular bisector. Let's just multiply this out, and we'll see what we end up with. So multiply this side by 2, because I'm dividing by 2 on this side. That'll give me 2y minus 12. Multiply this side out by the 3. That'll give me 3x minus 21. And from there, I'll just gather everything to the right hand side. 0 is equal to 3x, gather the 2y over there, minus 2y, and I've got minus 21 plus the 12 should give me a minus 9 on that side there. Okay, so that'll be part B complete there. For part C, what we'll go ahead and do, we'll try and find the point of intersection of the lines found in A and B. Okay, so let's start with the lines that we've got. So there's the first line and the second line. I'll just take the bottom part there that I worked out. So that's equation 1, that's equation 2. So if I was going to do it by simultaneous equations, that's the way I would do. What I'll do to find the point of intersection here, I'll just substitute equation 1 into equation 2. So I'm just going to substitute equation 1 into equation 2, and all that's going to be is wherever I see x, I'm going to substitute the 4 in. So 0 is equal to 3 times 4 minus 2y minus 9. From there, just gathering it up, so take the 2y over to this side, that will be 12 minus 9, 2y equals 3. So for here, my y coordinate will be 3 upon 2. And all I'll write down here is the point of intersection is going to be equal to my x coordinate, which was 4, my y coordinate, which is 3 upon 2. And that will be that question complete. Okay, we've got 7 marks to be gained here. So the first mark's going to come along where we just write down this equation here. So that's the first mark that's coming here. Next mark for the midpoint, for the gradient of BC, and then the perpendicular gradient, and then for substituting into the equation of a straight line. So that'll be 1, 2, 3, 4, 5 so far. And then for part C, we've got 2 marks coming out here. We'll go for 1 mark for knowing to substitute or to solve through simultaneous equations in some way, and we'll get a point of intersection, the mark for this one here. So total for this question is out of 7.